Let's learn a bit about cultivating microalgae as opposed to macroalgae for enhancing ocean carbon dioxide removal, Ocean CDR. So microalgae cultivation, again, you have natural processes of carbon uptake, photosynthesis. Microalgae need lots of nutrients, nitrogen, of course, nitrate, which is like urea, ammonium, and so on we put on land, and phosphorus and iron are nutrients that are necessary but are not as abundantly available as nitrogen in the oceans. Often you hear about phosphorus limitations and iron limitations, so iron fertilization is one of the methods of doing this as well. We'll separately discuss artificial upwelling as well, but here is artificial upwelling bringing nutrients from the deep ocean to the euphoric zone or the sunlit region to support photosynthesis. It also brings trapped carbon from the deep ocean to the surface ocean, which can increase the partial pressure of CO2 in the surface water, which can drive outgassing. So you have to be very careful about what you do there, and you have to monitor. Monitoring, reporting, evaluating is always critical for any human activities, any projects, right? Whether it's resilience, adaptation, geoengineering, and whatever other improvements you're planning to make. Unless there is reported evidence, it can just amount to greenwash and so on. So additional nutrients in nutrient limited areas cause growth of microalgae, which can increase ocean uptake of carbon dioxide from the atmosphere. So photosynthesized production of organic carbon can drop out to the floor as carbon sequestered in the deep ocean. It falls on the sediment. There are some bioturbation, there are microbes living there which do their work, but eventually you expect some sequestration to happen, which gets compressed, metamorphized into calcium carbonate, limestone and other things which come up during geologic activities like plate tectonics and so on. So you have also some carbon that sinks to ocean floor as biomass and not just carbon. And of course some carbon is recycled as nutrients and carbon dioxide, so gets back. And of course if you look at the numbers of molecules, you expect many more to go in and very few to come out if you do it correctly. But in the background the ocean is warming, the solubility is going down, and deoxygenation is happening, and so on and so forth. So you can also cultivate microalgae in the shore-based facilities, farming of microalgae on land. So they can be used for long-lived low carbon products that we talked about before, and we can sequester microalgae in the deep ocean directly, or can bury microalgae in underground reservoirs. Even on land now, people are advocating growing forests and burying them. And this is led by Ning Zheng from the University of Maryland. Again, life cycle analysis, growing forests, cutting them down, putting in the ground long enough, but how much land are you going to use? How are you going to put it for long enough? And all those good questions come for any form of carbon sequestration you are trying to do. And it's always a question of how many places are there where you can put it safely away and not do any unintended circus with our activities, which almost always happen. So just remember macroalgae versus microalgae. There are significant differences. Actually, these macroalgae forests, even like mangroves and so on, not only are they good for oxygen habitats, fishing and so on, but they also very strong protection against storms, of course. But also remember that they can sequester 3 to 10 times more carbon than land forests, and they don't burn down, people. On land you have more and more wildfires burning down forests, and boom, putting all the carbon back in a second that has been sequestered over decades into nice lush vegetation. So blue carbon has many advantages. So leave this again here, short podcast, and come back and talk about artificial upwelling and downwelling. Why is there no? Yeah, we'll see what is next. Okay, so we'll keep adding podcasts. I think we just have a couple of more to this topic of ocean CDR.